This is the video answer key for the final exam review in Math 1111 through eCore. And I wanted to let you know that there is a formula sheet given at the beginning of both the final exam review as well as the final exam that you'll have reference to during the final exam. So let me show you some of the things that are on there. It's at the very beginning of the document, okay? You have distance, midpoint, slope, point slope, equations for both vertical and horizontal lines, the various forms of quadratic functions, the formula for the vertex of a quadratic function, the discriminant, the quadratic formula that can be used to solve quadratic equations, the compound interest formula for compounding yearly, monthly, semi-annually, or continuously, the change of base for logarithms, the various properties and laws of logarithms, equation of a circle, difference of two squares, difference of two cubes, sum of two cubes, equation of a line and slope intercept, and the various transformations of functions, average rate of change, the half-life formula. So all of those formulas are available at the beginning of the final exam. You are allowed to use your notes. You are allowed to use example problems. However, there is a 2-hour time limit to the final exam. So that's kind of the one restriction. So you may want to have yourself organized, have your notes. The final exam is limited to 2 hours. So I want to work through the problems here that are on the review or the practice final exam. And so question number 1 says factor the following. So guys, it's important that you pay attention to the instructions because oftentimes the instructions will give you a clue about how to work the problem. And this particular problem says to factor. Now, there are multiple techniques for factoring. You can do trial and error. Some students over the years have learned the box method. Some have learned how to rewrite it in terms of 4 terms. And so there's various techniques. I'm going to use the box method here just because it's one of the easier ones, I think, once you have an understanding of that particular method. So I'm going to draw a box, and I'm going to divide it into 4 individual sections. The first term goes in the upper left corner, 16x squared, and the last term goes in the bottom right hand corner. I'm then going to multiply those two things together. 1 times 16x squared is 16x squared. And then I'm going to think about all of the pairs of numbers that would multiply and give me 16. So I've got 1x and 16x. I have 2x and 8x. I have 4x and 4x to get the squared. I need to find the pair of numbers that will add to 8. So 1 plus 16, that is not 8. 2 plus 8 is not 8. 4 plus 4 is 8, and I want to have a negative 8. So both of these numbers are negative, and they go in the remaining 2 boxes. And then I am going to go basically around the box for each row and each column and find the greatest common factor. So for the top row, 16x squared minus 4x, I have a 4 and an x in common. For the bottom row, we always use the sign here, so I have a minus. 4x and 1, the only thing they have in common is a 1. Then I'm going to check the columns. First column, 16x squared minus 4x. Again, I have a 4x in common. I'm going to use the sign here. 4x and 1, again, I only have a 1. So the expression that is on the column and the expression on the rows, this piece and this piece, are now my factors. So 16x squared minus 8x plus 1 is 4x minus 1 times 4x minus 1, which can also be written as 4x minus 1 squared. The next question says, solve the following equation for x. So my goal is to solve the equation for x. The first thing I want to do is try to simplify everything by getting rid of the parentheses. So I'm going to go through the process and I'm going to distribute. And I'm doing that to eliminate the parentheses. So negative 5 times x is negative 5x. Negative 5 times minus 4, or negative 4, is positive 20. Plus 2 comes down. Equals comes down. Negative 1 comes down. Remember, there's an understood 1 here. So 1 times x is 1x. 1 times 6 is 6. Then on each side of the equal sign, I'm going to combine like terms. We're going to combine like terms on each side. So I would have negative 5x, 20 plus 2 is 22, equals, got x, then I have negative 1 plus 6, which is going to be plus 5. Then I need to get all of the x's together. Okay, so I'm going to subtract x from either side to get all of the x's together. So I have negative 5 plus negative 1. Remember, there's an understood 1 there. That's negative 6x plus 22 equals 5. Then I need to move the 22 to the other side by subtracting 22. So I have negative 6x equals 5 plus negative 22 is negative 17. Then I need to isolate the x. So I'm going to undo the multiplication. I undo the multiplication by dividing both sides by 6, or negative 6, excuse me. So x equals 17 sixths. Negative divided by negative makes the overall answer positive, and 17 sixths does not divide evenly, so you leave it as a fraction. Question 3 says to solve the quadratic equation. Okay, so they identify it as a quadratic, and when you have a quadratic equation, you have two options for solving. One, you can factor, or two, you can use quadratic formula. Now, I anticipate that most of you probably will use quadratic formula, But I'm going to solve this one by factoring, and then number 4 is another similar problem, and I'll do it by quadratic formula. So again, if I'm going to solve this particular problem using the factoring technique, okay, so I'm going to indicate I'm doing factoring. Again, I could use the box method for factoring. Okay, so I'm going to indicate box method. So I would have the first term, x squared, goes in the upper left, minus 4, the constant, goes in the lower right. I'm going to multiply that together. There's 1x squared times negative 4 gives me negative 4x squared. Thinking about the numbers that will multiply to 4, I have 1x and 4x, 2x and 2x. I need to find the pair that will subtract to 3. 4 minus 1 is 3. 2 minus 2, that's not 3. So I need to have a minus 3. So the 4 is negative and the 1 is positive. So I'm going to put 1x and minus 4x. And then we go all the way around the box. Top row, x squared and 1x have an x in common. We use the sign here, so it's a minus. Minus 4x and minus 4, we have a 4 in common. First column, x squared minus 4x, we have an x. 1x minus 4, we use the sign that's there, it's an understood plus, and we have a 1 in common. So this factors as x minus 4, x plus 1, and that equals 0. We then apply the zero product property, which tells us that one of those pieces, either x minus 4 equals 0 or x plus 1 equals 0, and we solve each of those respectively for x. So I'm going to add 4, add 4. So x is 4. That's one of our solutions. And the other one, we subtract 1 from either side. We have x equals negative 1. So my second answer is negative 1. Question 4, again, it says solve the following quadratic equation. So the question does identify it as a quadratic. Again, we can solve a quadratic by factoring or by quadratic formula. So that you have an example of each and how to use quadratic formula, I'm going to solve this problem by using quadratic formula. The formula is given, just to remind you, on your formula sheet. You may have to go back to the top and look, and it's the quadratic formula right here. Okay, so the quadratic formula is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I think it's beneficial to write the actual formula there under the problem or wherever you're writing the problem out so that you have it. A, B, and C are your coefficients. A is always the coefficient on the squared term. B is always the coefficient on the x, and C is the constant. So if I plug into the quadratic formula, I would have the opposite of B, which is negative 13, plus or minus the square root of negative 13 squared minus 4 times 2 times 6 all over 2 times a, which is 2. So I've done the substitution, and again, I'm writing it out every step. So then I'm going to go back and do the calculations. So the opposite of negative 13 is positive 13, plus or minus the square root. Negative 13 squared. Negative 13 times negative 13 is positive 169. Minus 4 times 2 is 8. 8 times 6 is negative 48. All over 2 times 2 is 4. So I have, continuing to do the math, positive 13 plus or minus the square root. 169 minus 48 is 121 all over 4. Simplify again, simplify the radical. So I have 13 plus or minus the square root, the square root of 121 is 11 divided by 4. So again, you're going to ultimately have two different answers. You're going to have 13 plus 11 divided by 4, as well as 13 minus 11 divided by 4. 13 plus 11 is 24, and 24 divided by 4 is 6. So one of my answers is 6. 13 minus 11 is 2 over 4, which simplifies to 1/2. So the two answers that I have are 6 and 1/2. Okay, so this problem says find the equation of the line through the points negative 6, 4 and negative 5, 10, and write your answer in slope intercept form. Okay, so again, there's a couple of formulas you need here. One, ultimately, you want your answer in slope intercept form, which is y equals mx plus b. But to get there, I need to know the slope, and so I may have to calculate that. So the formula for slope is y2 minus y1 over x2 minus x1. And then we know we write the equation. Typically, we begin with the point slope form of the line, which again is given on your formula sheet. Let me scroll down and see if I can find it for you. Equation of a line in slope intercept. Point slope may have been at the beginning. Let's see. It was point slope. Okay, so you have y equals, and again, writing your formulas down is helpful, x minus x1 plus y1. Okay, so now that I kind of know, I've kind of gone through and realized, okay, I need the slope formula, I need a point slope formula, now we can begin to use them. Okay, so you have 2 points here. So the first point is negative 6, 4. I'm going to label it as x1, y1. The second point is negative 5, negative 10, and I'm going to label it as x2, y2. Again, taking that extra second to label it is going to help you keep things straight as you plug and chug into the various formulas. So the first thing that I have to do in this formula or this problem is to find the slope. Because to write the equation of a line, you have to know the slope and a point. And at the moment, I know 2 points. I don't know the slope, but I can calculate the slope by substituting into the slope formula. So I'm going to do that. So I would have y2, which is negative 10, minus y1, which is 4, x2 is negative 5, minus the negative 6. So I have negative 14 over negative 5 minus a minus is negative 5 plus 6, which gives me negative 14 over 1, or negative 14. So the slope for this particular line is negative 14. Then I'm going to use the slope and a point. It doesn't matter which point you choose to use. I am going to choose to use negative 6, 4, since I have it labeled as x1, y1. So I would have, second, we're going to plug into point slope. So I would have y equals negative 14, x minus a minus 6 makes plus 6, plus, what was the second point there? 4. And I'm almost home free there, but I need to put it into slope intercept form. To get to slope intercept form, we have to distribute, okay? So I'm going to distribute. I have y equals negative 14x, negative 14 times 6. You may want to get your calculator for that. So 14 times 6 is 84. So it's minus 84 plus 4. Finally, last step's going to be to combine those like terms. So negative 84 plus 4. So I end up with y equals negative 14x minus 80. And there's your answer. Okay, question 6 says to determine the intervals for the function shown below, for which the function shown below is decreasing. Okay, again, it's important that you pay attention to the instructions, and it's also important to remember when you're writing the interval is written in terms of x, and you do not include the endpoints. Okay. Now it doesn't indicate here, but I believe, if I remember correctly, on the quiz itself, the answers are written in interval notation. Okay, so we'll write them in interval notation. So remember, the idea of decreasing means it's going down. So if I start on the left and look at how this graph works, it does appear to be going down. And we started at negative infinity because the arrow's on the end, and we continue going down until we get to this point here, which is at the ordered pair negative 2, negative 7. The x coordinate of that point is negative 2. So we keep going down until we get to negative 2. We're not going to include the endpoint, so we use parentheses. Then it appears that the graph goes up for a little while till we get to this point, which is at 0, negative 3. And then it appears to be going down again. So it starts going down at 0, that's the x value, and keeps going through positive infinity. So there are two intervals where the function is decreasing. We usually connect those with this little u symbol, which mathematically means or. Number 7 says find the rate of change of the given function on the interval 0 to 4, and it gives you the function. Now, the average rate of change formula is given on the formula sheet that's at the beginning. Okay, let me scroll down and find it for you. Average rate of change is f of b minus f of a over b minus a. Okay, so ultimately the formula we need is f of b minus f of a divided by b minus a. And you may say, well, Miss Rawson, where are all those a's and b's and f's of b? Okay, where does all that come from? Okay, the interval gives you your a and your b. So the first number is a, the second number is b. Okay, just tells me I'm going from point A to point B. I'm going from 0 to 4. This is really a 3-step problem. Okay, so the first step, we have to find f of a, which for this problem means we got to find f at 0. So we're going to substitute 0 into the problem and work it out to get our answer. So if we do f at 0, we have 2 times 0 squared minus 0 minus 1. I'm going to work it out. 2, 0 squared is 0, minus 0 minus 1. 2 times 0 is 0, minus 0 minus 1. 0 minus 0 is 0 minus 1, which ultimately gives me negative 1. So A, if you want to be real deliberate about it, A is 0, f of A is negative 1. Then I have to go back and do the same thing, but I have to do B. So the second step is to find f at B, and for this problem that's f at 4. So we have to substitute 4 into the problem. So f at 4 would be 2 times 4 squared minus 4 minus 1. Again, I'm going to do the math. 2 times 4 squared, 4 times 4 is 16, minus 4 minus 1. 2 times 16 is 32, minus 4 minus 1. 32 minus 4 is 28, minus 1, and 28 minus 1 is 27. So again, if we're deliberate, that tells us that B is 4 and f of B is 27. So the third step is to actually find that average rate of change. Okay, plugging into find your average rate of change using the formula f of B minus f of A divided by B minus A. So if we substitute the answers that we found from the problems, from the questions above, we have 27 minus negative 1. Let me make sure I got that right, that I remembered it correctly. I did. Over 4 minus 0. So 27 plus 1 over 4, that's 28 over 4, which equals 7. The average rate of change, the ultimate answer here is 7. Okay, but it's a process. You can't just jump straight to 7. You have to find the other pieces first. Okay, so take your time. All right, let me see if I can make this a little bit smaller. Yeah. All right, this one deals with, question 8 deals with transformations of graphs. And so they want us to take this graph, which looks like a parabola, and perform these transformations. And you're given graphs to match. So you have to understand the transformations. If you have forgotten those, they give you some insights into that on the formula sheet with transformations of graphs. Okay, but I remember that this little +2 out here at the end is a vertical shift. And since it's positive, that tells me I'm going to go up 2 units. I also remember that the -1 inside the parentheses is a horizontal shift or a horizontal translation. And I also remember that it's backwards. Since it's a minus, it's actually going to go to the right. It's backwards to what you would think. So it goes right 1. So to create this new graph, I'm going to focus on a couple of points. So if I focus on this center point, which is at 0, 0, and then I perform those transformations so that I have to move it right 1 and up 2, my new center point is going to be at this point. I could also look at, if I need a couple other points, maybe use this point here at 2, 2, but I'm going to shift it right 1. Okay, so this point I'm going to go right 1 and up 2. So it would be at this point. I could also do the same thing on the other side with the point -2, 2, and I could shift it right 1 and up 2. And again, that just gives me the new location. So my new graph, I'm going to need to look for where my center point is at 1, 2, and it also includes the points 3, 4, and -1, 4. Again, it just gives you the basic idea. You got to remember how to shift it up, down, left, and right. All right, question 9 asks you to determine which of the following graphs is 1 to 1. Okay, if you'll remember, to decide whether a graph is 1 to 1, we use, the horizontal line test. And a horizontal line can only cross the graph at most once, one time or less. So if I look at this first one and think about drawing a horizontal line, I notice that I cross 2 times. So that particular function is not 1 to 1. If I look at the graph to the right, I could draw lines in different places and I only cross 1 time. So this one would be 1 to 1. A lot of folks seem to think right here at this little curved area it might go flat. It never goes flat. Bottom left, again, I can clearly see where I could cross the graph 2 times, which means that particular function is not 1 to 1. And finally, the bottom right, again, we can draw a horizontal line in various places. Again, it never truly goes fully horizontal. So this one also is 1 to 1. So to decide if a graph is 1 to 1, you use the horizontal line test, and the horizontal line can only cross the graph at most one time. Okay, question 10 says for the functions f of x equals 2x minus 3 and g of x equals 5x plus 5, find f composed with g and x. Okay, so it's important that you remember that this little symbol means composed. Okay, so this is a composition, which means I have to substitute the x into function g first, get the answer, and then substitute it into function f. So in a sense, we're going to take x, I'm going to plug it into g, get the answer, and then plug it into function f. And I'm going to try to color code these for you. So let's make function f this light blue. And let's make function g this pink color. Okay, so initially I'm going to take x and plug it into function g. So if I take x and plug it into function g, I get 5x plus 5. Okay, so then I have to take the 5x plus 5 and substitute it into function f wherever there is an x. So I would have 2 times the 5x plus 5. I'm replacing the x with 5x plus 5, and then you still have the minus 3 that's part of the original function. Then I'm going to have to simplify. So I distribute the 2. 2 times 5x is 10x. 2 times 5 is 10 minus 3. Combine like terms, 10x plus 7. So f composed with g at x is 10x plus 7. Remember, compositions, it's a specific order, and you kind of work your way backwards. You substitute x into g, get the answer, and then plug it into f. Number 11 says find the inverse of the following 1 to 1 function. Okay, it's important to know that it's a 1 to 1 function, because a function must be 1 to 1 in order to even have an inverse. If you didn't know that, you would need to determine whether the function was 1 to 1, but they tell you that in this problem. And we want to find the inverse. Okay, to find the inverse, the first step is to interchange the x and the y. But remember, y is the same as f of x. So if I interchange x and y in this problem, I have x equals negative 5 times the square root of y plus 4 plus 3. So I interchange x and y. Then the second step is to do the algebra so that I can solve for y. So initially, the first thing I would do is subtract 3 from either side. So I would have x minus 3 equals negative 5 times the square root of y plus 4. Okay. Then I'm trying to isolate the radical, at least initially. I'm going to divide both sides by negative 5. So I have x minus 3 over negative 5 equals the square root of y plus 4. I then need to get rid of the radical. To get rid of the square root, we're going to square both sides. So I have x minus 3 squared over negative 5 squared, which equals y plus 4. Now I'm going to do a little bit of simplification here. On the left-hand side, I would have x minus 3 squared over negative 5 squared is positive 25 equals y plus 4. So to get to the end, I need to subtract 4 from either side. Now this is going to look messy. You're going to have x minus 3 squared over 25 minus 4 equals y. That y, once you have that solved for y, that function represents f inverse. So the inverse of the original function is this equation right here. Okay. The process: interchange x and y and then solve for y to find the inverse. All right, question 12 asks you to determine the vertex of the parabola whose graph is given. So you have to remember some of these terms. Okay, you have vertex. The vertex is the point where the graph changes direction. It's also the point, it's either your relative minimum or your relative maximum. In this case, since the parabola is inverted or turned upside down, it is going to be a maximum. And so it occurs at this point, and you need to identify that point. Remember, an ordered pair is always written x comma y. So I'm at negative 5, positive 5. And that represents the vertex of my parabola. Guys, don't overthink it. Okay, 13, again, is a graph. It gives you the parabola, and you want the x-intercepts. The x-intercepts are where the graph crosses the x-axis. It intercepts the x-axis. And there are 2 points. You have one on the left, which is at the ordered pair negative 5, 0. And you have one on the right, which is at 2, 0. All right, question 14 says determine the end behavior of the function. Now, there are two ways to do that particular problem. Again, you can remember the rules, or it may be helpful to look at the graph. That's the simplest way. The other way is to use the rules. So I'm going to enter this equation into my calculator and look at the graph. That's going to be the easiest way to do it. Don't make your life harder than it has to be. Okay, so I'm going to take that function to my graphing calculator, and I'm going to enter y equals x raised to the third power plus 3x, whoops, sorry, I'm hitting the wrong buttons, x raised to the third plus 3x squared, whoops, again, miss squared, minus x minus 3. Okay, so you have the equation x cubed plus 3x squared minus x minus 3, and I'm going to graph it. And I can clearly see that the graph goes down or falls on the left and rises on the right. Okay, so let's go out and look for just a quick minute. I can get over to question 14, and it uses the terms goes up on the left, down on the right. Okay, so we're just looking at what it's doing. So this particular graph goes down. Whoops, sorry, I'm under the wrong problem. Okay, if we look at the graph, it goes down on the left and up on the right. Let's look at it again. Okay, goes up, or if you're looking at it on the left, it's going to go down, and it's going to keep going down forever. So it goes down on the left and up on the right. Okay. Now you can remember the rules. Remember, this is the leading coefficient test. Okay, if you want to go by the rules, okay, but quite honestly, I would use the graph. It is the leading coefficient test, and you have to consider the degree, which is your highest exponent, and the sign of that lead coefficient. And when you do that, there are 4 options when you consider those rules. Okay, so when you consider those rules, there's going to be 4 options, and I'll outline them for you here in case you want to have them for the test. If your degree is even and your leading coefficient is positive, it's going to go up on the left and up on the right. If your degree is even and your leading coefficient is negative, it goes down on the left and down on the right. Notice when the degree is even, both ends do the same thing. When it is even, both ends do the same thing. When the degree is odd and your leading coefficient is positive, as it is in this case, it goes down on the left and up on the right. If the degree is odd and your leading coefficient is negative, it's going to go up on the right and down, up on the left and down on the right. It's going to go up on the left and down on the right. Again, notice if it's odd, the ends do opposite things. Okay, so those are the 4 guidelines, but I'm telling you guys, the easiest thing to do is look at the graph. Okay, look at the graph. Now, question 15 says, use the rational zero theorem to find all the real and imaginary zeros of the following polynomial function. Okay, this is a polynomial. It's not just a regular old problem. It's not a quadratic that can be factored. The option we have, and again it tells you this, is to use the rational root or rational zero theorem. Okay, so if you remember the rational zero theorem, it gives us a list of possible zeros by looking at the constant compared to the leading coefficient. So for this problem that we have here, my constant is 3 and the leading coefficient is 1. This would be your constant, and your leading coefficient is the number in front of the highest exponent. So if I think about all the numbers I can multiply together and get 3, it's going to be plus or minus 1 times plus or minus 3. And then for the denominator, I can have plus or minus 1. So my options are plus or minus 1, plus or minus 3. So I have 4 possible options. And at that point, guys, it does become trial and error, and we do have to use synthetic division. So I'm going to set up my synthetic division. I have 1, 3, -1, -3. And I'm just going to choose a number. It doesn't matter which one I choose. I can choose one of those 4 options. I'm going to start with 1. So I drop the 1. 1 times 1 is 1. 3 plus 1 is 4. 1 times 4 is 4. -1 plus 4 is 3. 1 times 3 is 3. And I get a remainder of 0, which tells me that this value of -1 is a 0. Since I started with an x cubed and I have divided one out, I now have x squared plus 4x plus 3. I now have, since I've divided one of those out, this is a quadratic. And so I could, at that point, either factor or do the quadratic formula instead of continuing with the process of trial and error. I should probably check for multiplicity. I should determine if the 1 occurs a second time. So let me check it. Okay, 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. It's 8. Okay, so it doesn't work a second time. So there's no multiplicity. So again, I have the option. I think I'm going to try to factor this thing just because it's a little bit faster. So again, if I use my box method that we've talked about earlier, I would have x squared in the upper left and 3 in the lower right. 1x squared times 3 is 3x squared. I would have 1x and 3x, that's the only option, and it adds to 4. It does add to 4, and we want them both to be positive, so I have a 1x and a 3x. And then going to find the common factor all the way around. So I have x, a 3, an x, and a 1. So it factors as x plus 1, x plus 3 equal to 0. So I know that one of those pieces, either x plus 1 was 0 or x plus 3 was 0. If I solve each, I have x equals -1 or x equals -3. So I have actually determined that my solutions are +1, which we found using synthetic division, -1, and -3. And since it was an x to the third power polynomial, go back up here and look, you had originally x to the third. Remember that highest degree tells me that I should have 3 solutions when I'm finished, whether they're real or imaginary. And I do have, in this case, 3 real solutions. Okay, so number 16 says an account is opened with an initial deposit of $100 and earns 4% interest compounded monthly. What will the account be worth in 25 years? Round your answer to the nearest dollar. So this is a compound interest problem. And I mentioned to you earlier that they did have the compound interest formulas here. This one says monthly, so it's important that you choose the correct formula. Okay, so here are your interest formulas. The first one here is the one that you use when you have monthly, quarterly, semi-annually, or annually. So again, I'm going to write down my formula, which is A equals P times 1 plus R divided by N raised to the NT power. And from reading the problem, I need to be able to identify all of those pieces. It says my initial deposit was $100. So that's my P, or my principal. That's what I started with. We earn 4% interest. You do have to convert that to a decimal. Remember, divide by 100. It's compounded monthly, which means within a year they're going to do it 12 times because there's 12 months in a year, and we want to know what it would be worth in 25 years. So we're looking for A. So it becomes a substitution problem. We're going to substitute those values into the formula. So I have A equals 100 times 1 plus 0.04 divided by 12 raised to the 12 times 25th power. Okay, I'm going to work it out piece at a time. We would start with the parentheses. So we would have 1 plus 0.04. Let's see, clear this out. 0.04 divided by 12 is 0.003333. Okay, so we have 0.003333, repeating, raised to the 12 times 25. Okay, so I'm going to multiply 12 times 25, which is 300. Okay, so then we have 100. We add these two together, so we get 1.003333, repeating, raised to the 300 power. Okay, so when I get to that point, I'm probably just going to use my graphing calculator, okay, to do it. So let's go over to the graphing calculator. We've done, start over, we did 0.04 divided by 12. We have to add 1, then have to raise that to the exponent 12 times 25, get the answer, and then multiply that times 100, which was the initial amount of money. So we get 271.38 if you round it to 2 decimal places for money. Okay, so this becomes 271.38. The instruction said round to the nearest dollar. So to the nearest dollar, we would have $271 after 25 years. All right, question 17 asks you which of the following is the graph of log base 7 of x, and it gives you 4 different options. Again, the easiest way to do this is going to be to create that graph in your calculator. So we would go to y equals, clear out the one that's in there, then we use math, and we scroll down the list to option A, log base, enter. I tell it I want log base 7 of x, and we're going to graph. Now, our scale may not be the same as the ones on the graph, so it may make it difficult to choose. Okay, so let's see. They're counting by ones here. Ones there. Okay, so I can kind of tell from looking at the graph on my calculator that it's not the third one because it's not turned that way. And it's not the fourth one because look again at your graph. It appears to kind of come up. Okay, so I'm down to, I had 4 choices. I've eliminated 2. And I can tell in both cases that we cross. It might help us to look at the table. Let's see, 1, 0. So I need that point on both graphs. So let's see. I've got 1, 0 here and 1, 0 here. Okay, that hadn't helped me any. Okay. Then let's see if we can maybe tell another point from our graph. Let's see. When I get to 7, I need the point 7, 1. Okay, so 2, 3, 4, 5, 6, 7. Okay, this one has the point 7, 1. This one 2, 3, 4, 5, 6. 7, it's above 1. Okay, so it's not this one. It has to be the first one. Okay, use your graphing calculator, eliminate the choices you can, and then look for key points. All right, question 18 says to find all the intercepts, both x and y. Okay, so again, it's important, guys, that you pay attention to the instructions. So they want you to find both the x and the y-intercepts. It doesn't matter which one you find first. The y-intercept, remember, is found by letting x equals 0 and we solve for y. So if I do that, I would have 0 squared plus 7 times 0 minus 18 all over 0 plus 3. So we'd have 0 plus 0 minus 18 over 3. It gives us negative 18 over 3, or negative 6. So our y-intercept is 0, negative 6. If you'll recall, to find your x-intercepts, you let y equal 0, but there's a shortcut when you have a rational function. You let the numerator equal 0. Okay, so we could use our shortcut here. Our shortcut, so we would have x squared plus 7x minus 18 equal to 0, and we need to solve for x. Again, since that is a quadratic, we could solve by factoring or by quadratic formula. I'm going to use trial and error here. Okay, a pair of numbers that multiply to 18 and subtract to 7 are 9 and 2. 9 times 2 is 18. 9 minus 2 is 7. The 7 is positive, so the bigger number, which is 9, needs to be positive. So I solved that one by trial and error. Then I know that one of these pieces, either x plus 9 was equal to 0, or x minus 2 was equal to 0. And then I have to solve each of those respectively for x. So subtract 9 from either side. So I'll get x equals negative 9. Add 2 to either side. X is 2. So we end up with the the x-intercepts are negative 9, 0, and 2, 0. So you'll actually have three answers. You have one y-intercept, which was 0, negative 6, and you have two x-intercepts, one at negative 9 and one at positive 2. And that's it.